Wait for nothing, sir.
Okay, 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 okay.
Okay, sir. I will start. Uh, Good morning, sir. Good morning, all. Uh, I would like to introduce the session of speaker of this session, afternoon session, Dr. A.H. and Kishore, Assistant Professor, Department of Computer Science Engineering, PhD College of Engineering and Technology. Dr. A.H. Nandakishore received his bachelor's degree in computer science and engineering from KLN College of Engineering, Madurai Commonwealth University in 2004. He completed his master's degree in the same discipline from Jerusalem College of Engineering and University, Chennai, 2007. He completed his PhD in the Faculty of Information and Communication Engineering at Anna University, Chennai in 2018. He published 15 papers in national and international conferences and journals, and he has more than 15 years of experience. His research areas include medical image processing, data mining, and natural language processing. This small introduction about the speaker, I hand over this session to the speaker, Dr. A.H. Nandakishore. Welcome, sir.
Thank you, ma'am. Thank you for your brief introduction about me.
Thank you. Yes.
So, good afternoon, all. So, I welcome all the delegates for attending this meeting. Uh, and before starting the session, ma'am, is it audible to all?
It's audible, sir.
Yes, sir, it is audible.
Audible, sir, and the
Okay,
screen is also visible.
visible. Okay, okay, okay. Thank you, thank you. So, once again, good afternoon and all. So I take this opportunity to thank for giving me an opportunity to present a topic in this wonderful ACT sponsored 60 Sttp on biosensors, medical imaging, and signal processing techniques for disease diagnosis. Uh, I have to thank our management principal sir for supporting such a kind of programs. I have to thank our beloved biomedical department HOD ma'am, Dr. E. Jayanti ma'am, for giving me an opportunity to present a topic. Uh, Thank you, ma'am. I thank the organizers, Dr. Sudha ma'am, and other faculty team members. Those are wonderfully organizing this 6 days program. So with
Thank
this, thank you, ma'am. So with this, I would like to start my presentation on classification algorithms. The topic that I have chosen and wanted to present to you all is the classification algorithms. So you may be thinking it's a very difficult topic related to Sttp. Anyhow, it will be very much useful for implementation purpose. So, so for any problem, so we need to have an algorithm to solve that problem. So whenever we are having a problem, we need to understand and analyze the problem, and then we are coming out with the solution steps, what we call the algorithm. Uh, Once you design that algorithm, deviation algorithm, we will be having a system overview and other things where we know how to provide the input for the problem. So how we are going to transform that into information. Okay, so for any problem, we need an algorithm. So here for classification, so we have taken two important algorithms, and I would like to compare the two algorithms and see which is a better one. Uh, Apart from that, I would like to have present a case study. Okay, so the IBIS flower species classification, both of these two algorithms. So later on, I will give you a small presentation on a case study on medical image processing. So we can apply these two algorithms along with that medical image processing, and we can compare and contrast the uh, results. We can compare and contrast the results. That will be given as a case study for that. Okay, so KNN algorithm and navigation algorithm. So hope everyone have come across these two algorithms. So KNN algorithm is nothing but the K nearest neighbor algorithm, and it's a supervised algorithm, supervised machine learning. So both are machine learning algorithms. Classification comes under machine learning algorithms. So K nearest neighbor algorithm. This navigation algorithm, it is probability based algorithm. Okay, so we are going to discuss on these two. So the topics to be covered in the presentation, it includes the definition for machine learning, introduction on machine learning, and what is classification, a brief introduction on classification, what are the terminologies that are involved in this classification process, what are the various approaches that are present for classification, what are the classification methods that are available. So in that two models, we can discuss. One is a K nearest neighbor classifier and Bayesian classifier, and we'll discuss on applications of classification. So machine learning. So this is a buzzword now. So machine learning. So machine learning, deep learning, artificial intelligence. These things play a very important role in the case of implementation of any problems nowadays. So we should know what is machine learning. So hope you would have come across machine learning. So machine learning is a subset of artificial intelligence, which provides the machine to think and learn automatically with its previous experience by training and testing. So the machine learning comprises of a set of computer algorithms, so which we need to train to that, and it is going to learn from the experience without being explicitly programmed. So whenever it is going to run for each and every iteration, so it is going to get trained well, and it will be it will be learning from the from the experience. And when a new set of data is given, okay, based on its previous experience, it is going to provide the desired target result. So classification, next is classification. It comes under one of part of the machine learning process. So classification is nothing but a data mining technique. So where we need to mine the data and get the knowledge from the data. So nowadays we are having huge volume of data. So getting analyzing the data and getting the information is like getting a needle in a haystack. So we need some efficient algorithms, so with which we can classify the data very easily, and should come out with the results in a very faster manner. So classification is a data mining technique where we need to categorize the data into a number of given target classes. So we'll be having a set of target classes. So for the given input data, we have to map those input data with that of the target class. So the goal of a classification problem is nothing but to identify the category of a target class to which the new data is going to come under. So under which category it is going to belong to. So we have to identify it and we have to label the data. Okay, so that is what is called as classification. So it is a form of a data analysis where we are going to extract the models and describe the data classes. So here let me give some general example you can see in the slide. So we have a bank loan officer who is going to analyze the loan data. Okay, so we are analyzing the loan data, the customer data, customer personal data like as age, salary, etc. And it is whether safe to provide that loan to that particular person or whether it is risky. So we need to classify. So that is one of the classification problem. Another one is a marketing manager at a company needs to analyze customers' records and they wanted to check whether the person will buy a computer or not. Okay, so if he or she buys a computer, what are the other peripherals they'll be needed? Okay, so all these things will be very much used for real-time applications. So where we can use it and analyze that. Okay, so nowadays. Mm, Even when we go for online purchases. Okay, so if you are purchasing some items, so related to all other items, they are going to display it. So they wanted to uh, show all those things and wanted us to buy. Okay, so we call it a market basket analysis. Okay, so make other. So if you are going to purchase one product, apart along with that, they will show us to purchase other products also. So for example, if you are going to a supermarket, if you see all the related items will be arranged in a particular shelf. So for example, all the detergent powders, cakes, everything will be in a single row, and all the other food items will be in single row, so that we can check which we need to buy. Along with that, what are the other things we can buy it. So they will show that. So we may plan to buy one product. Apart from that, they will show some other products and they will increase our eagerness to buy other products also. So it is a company trick to increase their profit. So it's one of the best example uh, where it's a real-time example where to classify the products and place it in particular shelves. Okay. So classification terminologies, you can see what's a classifier. So classifier is nothing but an algorithm which is going to map the input data to a specific category. Okay. So classification model. So a classification model tries to draw some conclusion from the input values given for training. So it will predict the class labels or categories for the new data. So next is a feature. So a feature is an individual measurable property. So which is going to be given as an input for the classifier. So based upon the set of features, we are going to come out with the mapping of the target class. Next is a binary classification. So the classification or a classifier is going to have only two possible outcomes as the output. So then it's called as a binary classifier. For example, yes or no, or gender classification, male or female. Okay. So if it is going to include only two possible outcomes, then we call it binary classifier or binary classification model. Then multi-class classification is nothing but a classifier which is going to involve with more than two classes of outcomes. Okay, so here multi-class classification, each sample will be assigned to one and only one target label, but we'll be having more than one target to be present. So an animal can be a cat or dog, but not both at the same. So more than one animal will be there. So we have to uh, target that and we have to apply the correct class label for it. Then multi-label classification. So classification task where each sample is going to be mapped with a set of target labels. For example, a newspaper article will belong to more than one label. So it may include sports article, it may include a person, it may be including a location. One for one input thing, so it will be labeled, it will be mapped to more than one class label. So that is a multi label classification. So that's the difference between multi-class and multi-label. Okay, so same thing may be mapped to more than one label is multi-label. If one thing is going to be mapped as one target label, but more than one target label is present, then it's a multi-class classification. So next is a general approach to classification process. So data classification is a two-step process which is going to consist of a learning step as well as a classification step. So learning step, it's a classification model is constructed in that particular step. So once the classifier is designed, so we can go for the classification step. So the classification model is used to predict the class label for a given data. Okay. So these are the two steps that are going to be generally involved in data classification process. So here in classification, we are having so in machine learning, we are having two categories of classification. One is supervised learning, another one is unsupervised learning. So in supervised learning, classification comes under supervised learning, where the machine is going to be trained using the data which is already labeled. Okay, so the trained data will contain the class labels. So along with the class labels, will be training that. So class labels of the training data will be known in well in advance. So when a new data is going to be coming, so based upon the previous experience, it is going to provide the class label to the new incoming data. Okay, so that is supervised learning. In unsupervised learning, the class label of the training data will not be known. So based upon the features, it has to identify to which cluster or to which category it has to place the particular input. So given a set of measurement observation, the new incoming data has to be assigned to particular cluster. So clustering comes under unsupervised learning, so which is not beyond our topic now. So we are mainly going to concentrate on a supervised learning process, that's the classification.
எதுக்கு
Excuse me, sir. So supervised versus unsupervised machine learning. So machine learning, we are having two categories. One is supervised learning and unsupervised learning. So in supervised learning, we are going to develop a predictive model based on both input and output data. Okay. Whereas in unsupervised, we are going to group and interpret the data based only on the input data features. Okay. So classification regression comes under the supervised learning and clustering comes under unsupervised. So here in learning step, we are having training data. For example, we can see that. Okay, so we are having name, age, income. Okay, as the input features. We are having the input data for those features also, and we are going to come up with a loan decision. So first example, what we have seen the previous slide. So the bank loan officer they wants to check whether it is safe or risky to provide the loan to that particular person. So if the person is young and income is low, then it will be risky. If it's a middle-aged person and income is high, it is going to be safe. So based upon these features, the classifier it is going to design with the classification rules, that is ICHAN rules, what is called as classification rules. So if age is going to be youth and then loan decision is going to be risky. So these rules we call the association rules, and we are having a separate task or a separate concept what is called as a association rule mining. So we need to calculate the support and the confidence, all those things in order to remove all the unnecessary rules, and we can optimize the classification rules. So that is a separate part in the data mining. So at present, we should know what are classification rules. So based upon these classification rules, internally, if you are going to design your neural network or design your own classification algorithm, we can utilize these classification rules and we can provide the target labels. So after training the system, so we'll be having a test data. So you are going to provide the test data and you are going to run the classifier and see whether what's the output you are getting. And you are giving a new data which is not present in training or test data. And you are saying what is the outcome of that particular classifier. So here, John Henry as a new person, middle-aged, and the decision is on the salary, that is income is low. So what's the loan decision? So automatically you can say the age is middle age and the income is low. So So what will be the loan decision? Can you tell me, uh, participants? We can unmute and see. So here the age is middle age and income is low. What about the loan decision? So here is I have shown here. So the loan decision is going to be risky because the income is low. So automatically it is very difficult for him to pay that loan. So the loan decision will be risky. Okay. So this how based upon the input features we need to write the classification rules and we have to come up with the target labels. Excuse. So here you are having various classifier algorithms, okay, classification methods. We'll be having statistical approach, we'll be having machine learning approach, we're having neural networks, we're having a C4.5 algorithm, 83, KNN Bayesian algorithms, KNN algorithm, Bayesian algorithm, support vector machine, FISCM algorithm, artificial neural network algorithm, Bayesian trees, support vector machine, sense clusters. So likewise, we have lots of classification methods that are available. So each and every algorithm has its own merits and demerits. Okay, you can apply that for both mm, normal input features as well to the machine learning process. So with this brief introduction, let me start about KNN classification algorithm. So the topic is K nearest neighbor classification algorithm. So K nearest neighbor classifier, or KNN classifier, it is a supervised machine learning algorithm, so which is going to classify the new data point into its target class depending upon the features of its neighboring data points. Okay, so based upon the similarity measures, we are going to provide the class label. So here, so for a general example I have shown here, so we are giving an input image to the KNN algorithm. So based upon the features, it is going to categorize into either a cat or dog. Okay, either cat or dog. So based upon the length of the ears as well as the length of the tail, so we will be having the features, so sharpness of claws and the length of ears. So it is going to categorize whether it is going to belong to cat or dog. So we have to see the similarity measures. We have to get the input feature details, and based upon similarity measures, we need to provide to the target class. So now the incoming data, if you see the ear is small and the tail is large, so automatically it will be similar to the cat. Okay, the input image is similar to the cat, so we are assigning that new incoming image to cat instead of dog. So we need to have set of input features and we need to have set of similarity measures to calculate and categorize into various class labels. So K nearest neighbor classification algorithm is a type of supervised machine learning, so which memorizes the observations from the labeled training dataset and test dataset to predict the class labels for the new incoming unlabeled observation. So when you are going to give a new incoming data, it is going to provide target labels for that. So it is used for both classification as well as for regression. Okay, so the following two properties would define this KNN algorithm very well. So one is a lazy learning algorithm. So KNN is a lazy learning algorithm because it does not have a specialized training phase. Okay, we have to train the system well, uses all the data for training while classification, and it is going to accumulate that experience. Okay, so later on when you are going to build the new input, it is going to categorize it to the target label. So next is a non-parametric learning algorithm. Does not assume any criteria about the underlying data. So we are going to have a k value. So based upon the nearest neighborhood data, it is going to provide a class label to the incoming new unlabeled observation. So here comes the working that KNN algorithm. So it uses a feature similarity to predict the values of the new incoming data points. So here a new data point will be assigned a value based on how closely it is going to match with the points in the training data set. So here we can see the working principle or algorithm of that KNN classifier. So step one, we have to load all the training data set as well as the test data set from the entire data set. So we can split it into percentage values for both training as well as test data set. We need to choose a value of k of the neighbors. So that is the nearest data point, and we have to do the following for each data point. The following steps we have to do. We have to calculate the Euclidean distance between the test data and each row of the training data. So once we have calculating the Euclidean distance, we have to sort the distance value based on ascending order. Okay, in ascending order, we have to sort the distance values. Based upon choosing the top k rows on the sorted array, we have to assign the class to the test point based on most frequent classes of these two rows. So this is the working principle behind the KNN algorithm. So steps involved in the KNN algorithm. So need for KNN classifier. So when we need a KNN classifier, suppose that we are having two categories, say category A and category B. So a new data point x1 needs to be assigned to a class, so that we need to identify the data point will lie in which of these categories. So in such cases, KNN algorithm will play a very important role. So for a binary classification process, KNN algorithm will play a very important role. So with the help of KNN, we can easily identify the category or class of a particular data set. Okay, so we are having a graph here. So before applying the KNN, you can see a blue point, so which is a new incoming data point. So we are having category A and category B representing green points and yellow points. So those are going to be the data set, input data set, and the experiment tested data set. So we are applying this gain, and we are seeing the distance similarity between x1 with the points in the category A and the x1 with the points in the category B. So since the data point is very nearest to that category A, we are going to assign the new data point of below as a category A, and we have changed it into green point because it is very nearer to the points that are present in category A. Okay. So how to find this distance? So what metric we can use to find out the distances? We have to use the Euclidean distance between the points. Okay, so we are having point A and x1 by 1. So we have to find out the distance between this A and B. So the Euclidean distance between A and B, the formula can be calculated as the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. It is one of the metric. So we can use any one of the distance metric like Manhattan distance or Euclidean distance or many metrics are there. So here we are considering Euclidean distance between A and B. So distance similarity metric here we are using is a Euclidean distance, and we are finding the similarity measure. So here one more thing we are having before classification, you are having set of data points, and category B you are having set of data points, yellow is a new data point. We are seeing how many nearest neighbors that are present. So for category A, you are having three neighbors. For category B, you are having only two neighbors when you are calculating the distance. So more number of data points close to the new data point is present only in category A. So we are assigning the new data point as category A. Okay. Here one more thing. So we are having class A and class B. So star is the new incoming data. So how to choose the k value? So if you are going to choose k equal to 3, so nearest to 3 neighbors we are going to find out. And how many nearest neighbors are there for the k value equal to 3? We have to see. So if your k value is going to be 3, you are having 2 neighbors. If you are going to choose k value of 6, you are having 4 neighbors in class C. So depending upon the k value, so the class levels will be changing. So we need to choose our k value in a better manner to get a better result. So there are no hard and fast tool to determine just that is determine the k value. So it depends upon the application. So we need to fine tune and see for each and every k value. So for which k value you are getting a better accuracy. So that k value can be fixed as a optimal value or threshold value, and we can use it in our system. Okay, it depends upon the application. So if you are going to use low k values, then it may lead to noise or yeah, outliers or errors. You may outlier effects you may see. If you are going to use large value, it is very difficult for us to categorize whether uh, for which class label we can assign. It will be becoming difficult. So most probably in most of the application, the preferred k value will be ranging between 1 to 5. So preferred k value is taken within 3 to 5. So that will be better option. So we are going to see one case study. So for which k value we are going to get a better result. So that we will see now in the forthcoming slides. So let us see one case study. So which is not much related to the medical image. So the same algorithms you can apply for your medical data also. So Canine classifier. So here I have taken iris flower species classification. I am applying Canine classifier on iris flower data set, and I am implementing the concept in a scikit-learn. Okay. So for input data, I'm considering the iris dataset from the University of California at the within uh, University ML repository, that is UC ML repository, machine learning repository. So we are having various data set present. Okay, so we can consider any kind of data set for which is suitable for our application. So here I am considering iris dataset. So we are having around 150 instances as inputs, and we are having four features, four attributes as input features, and there are no missing values, etc. Okay, so it's a multivariate, so data characteristics, attribute values are real values. Okay, so it is going to contain four attributes. One is a sepal length, sepal width, and petal length and petal width of the flower. So those are the four input attributes. So you can download from the UC machine learning repository. So these informations are obtained from that site only. So attribute information. So we are having four important things, four important attributes: sepal length, sepal width, and petal length and petal width, which are given in centimeters. Based upon these four input features, we are going to categorize into three species of iris. One is iris setosa, iris versicolora, iris virginica. So these are the three features of iris. Okay, these are going to differ in its sepal and sepal width. Okay, so that's the color. If you see, the sizes will be large when compared with Virginica and Setosa. So each and everything it depends upon the uh, size of the sepal and sepal width and petal length and petal width. Okay. So let us see the implementation steps. So the same thing we can apply for any other data set similar to this iris data set. We can take for disease classification also. Okay, so here I am showing for iris species classification. So the same way we can check it for disease data set also. Okay, so like our disease data set, we can import the data set. Okay, so here you can see from scikit-learn you have to import the data set. So from scikit-learn neighbors we can import the k neighbors classifier package. Okay, so Python code. So from scikit-learn model selection we have to import the train test split. So this train test split package, it will be helpful to split your entire data set into training data set and testing data set. In order to evaluate our algorithm, we are going to use a metrics package. So from scikit-learn, you can import a metrics package. Okay. So next step is we have to load the data. Okay, so in order to load the data from the data set, we are using iris as a variable. Iris equal to datasets dot load iris. When you do datasets dot load iris, so the iris dataset will be loaded. So once you type iris, automatically it will show all the values that are present in the data set. So four values will be there for each and every data. So one is the sepal length, sepal width, and petal length and petal width. So next we have to print, if you want to know what are the feature names and the target names that are present, we can see here. So feature names are going to be sepal and sepal width, petal and the petal width. So that is feature names. So which is given in the bracket, and the target names are going to be the three species of iris. One is 0, 1, 2, which represents Setosa, versicolor and virginica. So 0, 1, 2, here you can see if you want to see what are the target values, you can do print iris.target. So once you give print of iris.target, it will print the target labels, so which are numerical values. So set 0 represents Setosa, 1 represents virginica, and 2 represents versicolor. Okay. So now we have to split the data set into training set and a tested data set. So in order to do that, we are having x underscore train, comma, x underscore test, comma, y underscore train, y underscore test equal to train test split function. So train test split method, you have to call it, and you have to give the input iris.data, iris.target, let the test size be 30%, so 0.3 you are giving. So KNN equal to, now we have to call the classifier. So in order to call the classifier, we are using KNN equal to neighbors classifier of n neighbors. So this is going to be a parameter. So n neighbors equal to, you are providing as 5. So now I am choosing k value equal to 5. So let me check what's the prediction result. So in order to do that, we have to fit the training data. So KN and fit of X train from a Y train. So training data set is provided, and we have to check for the test data also. So KN and predict of X of test. So first we are training the system with the given training data as well as the target values, and we are going to see the prediction result for the tested data set. So for that we have to Y underscore predict equal to KN under predict of X underscore test. So once you call this method predict, automatically it will predict the class labels for tested data. So in order to check the accuracy, we have to print the accuracy of the model. So print of accuracy of the model is given as a, you have to use a metrics package. So metrics dot accuracy score is the method to print the accuracy. So metrics dot accuracy score of y underscore test comma y underscore predict. Because for the test set, what is the accuracy? We need to check. So y test is the test data, and y predict is nothing but the predicted class label. So for that we are checking accuracy. So our model has reached around 95.56%, and around 96% we are reached for k equal to 5. So the same thing, let us change the parameter value k equal to 3 now. So n neighbors change to 3, and let us train the system and see the prediction result. What is the prediction result? So here if you see, when our neighbor is going to be 3, automatically the accuracy of the model is going to be 97%. So we are reaching around 98%. So likewise we can fine tune our n neighbor value, and we can see for which or for our particular application what's the accuracy that is reaching. So we can fine tune and check that. So we don't have any hard and fast to fix that value. So there's no fixed threshold also. Okay, it depends upon the application. So hope you have got cleared how KNN can be implemented in scikit-learn using Python. Okay, so application of KNN classifier, let us discuss now. So KNN classifier can be applied in various fields like text mining. So where KNN algorithm is one of the popular algorithms for text categorization, for categorizing the text. Okay, so biomedical text or in text we can categorize, for that we can use it. In agriculture, we are using to evaluate the forest inventories and mainly used for climate forecasting and the prediction. And in finance, we are using for stock market forecasting. So which is one of the uh, most core financial task. Okay. So healthcare, we can predict whether a patient is having a particular disease or not. So for that, we can use the scan and classifier. So mainly this part is what we are much concentrating on now. Okay, so Canaan classifier can apply in healthcare data set, and we can check whether particular patient is having a disease or not. So, for example, heart disease data set, you can take it and you can apply the same algorithm, and you can see whether the patient is having the heart disease or not. So advantages, it is easy to implement. It is robust to the noisy training data. So it can be more efficient if the training data is very large. So it will get training well, and it will provide the class level efficiently, effectively when you train the system more. So disadvantages, there is no hard and fast rules or a particular thing to select a suitable value of k. So we have to fine tune it, and we have to check so for which k value we are getting a better result. Computation cost is also very high because it needs to calculate the distance between the data points for all the training samples, and it has to be done. So computation complexity of a KNN algorithm is high when compared with the other one what we are going to discuss now. Okay, that is new basic. Fine. So now you would have cleared about KNN classification. Now we'll discuss about new Bayesian classification algorithm. So Bayesian classification. So it is based on Bayes theorem. So Bayesian classification are statistical classifiers. They can predict a class membership probability. So it is mainly based on probability and assign a given tuple to a particular class. The Bayesian classifiers exhibit high accuracy and speed when compared with other things when applied to a large database. Bayes theorem, we'll see, would have learned about mathematics when we say Bayes theorem immediately you may go to your probability class. Uh, it plays a critical role in probabilistic learning and classification. Let X be a data tuple whose class label is unknown, and H be the hypothesis for which data tuple X belongs to your specified class C. Then the classification problem can be applied to this P of H given X, which is nothing but a conditional probability of H given X. We calls the conditional probability of H given X, which can be calculated using the equation P of X given H into P of H by P of X. So that is these are an equation. So we can apply this and we can calculate the posterior probability value. So based upon that, we can provide the class label. So the naive Bayesian classifier or simple Bayesian classification is a simple and a well-known supervised machine learning technique. It makes the assumption of class conditional independence. So class conditional independence should be there. So the values of the attributes are assumed to be conditionally independent of one another. Okay. So working of an Bayesian classifier. So let D be a set of tuples and their associated class label. So each tuple is represented by n-dimensional attribute vector x equal to x1, x2 up to xn, which depends depicting n measurements made on n attributes a1, a2 up to an attributes. Suppose we are having m classes c1, c2 up to cn. Then given a tuple x, the classifier needs to predict whether to which class it belongs to, depending upon the highest posterior probability conditioned on x. So that is the naive Bayesian classifier predicts the class label that is having x belongs to the class if and only if P of Ci given x should be greater than P of Cj given x for all 1 less than equal to j less than equal to m, and the j should not be equal to I. So P of Ci given x need to be maximized, so for which equals a maximum posterior probability or a hypothesis. So we need to obtain that value. So for maximum whichever it is reaching, so based upon that we are going to provide the class label. So P of Ci given x according to the Bayes theorem, which is nothing but P of x given Ci into P of Ci by P of x. So the representation of each and everything is shown here. P of Ci given x is posterior probability of C, which is where C is nothing but the uh, values on the target and given a predictor x attributes, and C is the posterior probability of that class. P of x given C is the likelihood probability, and P of x is the prior probability of the predictor. So let us see a basic example. We are having set of attributes, and we are going to see some weather details, outlook, temperature, humidity, and windy. Based upon the attributes of the weather, so whether the players are going to play golf or not, we need to classify. Okay, we are having the weather forecasted weather details. So with that we are going to forecast whether the players will play or not. Okay, that's the problem. So we have to solve that using this navigation classification. So here we have to convert the data set into frequency table. The steps are we have to convert data set into frequency table, and we have to create the likelihood table from the probabilities, like forecast probability and probability of playing. So here you can see from the input data, we have to see what are all the weather details we have, that the player will play or not. So from that table, we are coming out all these things. So now frequency table is we are having three attributes: forecast, rainy, and sunny, and we are having whether yes or no. So for yes, forecast we are having four. Rainy, the players will play three. That no is three and yes is two. Sunny, no means two, yes means three. So totally we have a grand total 5 and 9. So from the likelihood table, okay. So whether the players will play or not, we have to calculate. So we are having 14 input data. So for that we are calculating the positive probability 4 by 14. Totally, if it is rainy means 5 by 14. If it is sunny means 5 by 14. Yes means 9 by 14, and no means 5 by 14. Okay. So 0.36 and 0.64 for yes. And now we have to use these values and we have to come up with a prediction result. So here we can see, so players will play if weather is sunny, if this statement is correct. So the statement given here is players will play whether the temperature is sunny. Okay, now P of yes given sunny we have to calculate. So which can be written using the base here. P of sunny given is into P of yes by P of sunny. So we have to calculate each and every value. P of sunny given yes, we have to calculate from that likelihood table. It is 3 by 9, which is nothing but 0.33. So P of sunny is 5 by 14. Okay, 5 by 14, 0.36. And the P of yes is nothing but 9 by 14, that is 0.64. So from that we can calculate P of yes given sunny, which is coming zero point 0.6, which is having higher property. It is going beyond zero point 0.5. So the temperature is going to be sunny. Definitely, the players will play the match. Okay. So likewise, you can calculate the probability and check whether the players will play or not. Okay. So the same way, you can apply the disease data, and you can calculate the probability and check whether the patient is having prevailing a particular disease or not. So navigation classification implementation, the same way what we have done for KNN, you can do that. So you can load the iris data set, you can set the input data as well as target values in example. We can split the training and the test data from the scikit-learn data navigation. We can import the Gaussian navigation package, and you can call the function and you can pick the model and you can see the prediction gnb dot predict. If you give dot predict, gnb dot predict, automatically it will predict for the given test data and it will present the result in y predict variable, and you can check the accuracy. So metrics dot accuracy score, you can write y underscore test comma y underscore predict into 100 given. So when I give into 100, automatically it will come around 95.0. So in previous case, I have not multiplied with 100. So I have got in 0.955 like that. So once you multiply with 100, it will show that percentage. So for uh, this model, we have reached 92%. So here we are reaching 95. So there's a method to try fine tune your data using the k value. You can change and you can improve your accuracy, but here it's a fixed one. So for the given test set, what's the accuracy? Okay, so once you go and train the system, automatically the accuracy will improve. So more you train, so more is accuracy. So application of navigation classifier can be used for real-time prediction. Okay, so like weather prediction or something. Okay, so multi-class prediction is possible. In test classification, spam filtering, sentimental analysis, in all those cases to check whether the positive and negative customer sentiments. So there you can use this navigation classifier, and for recommendation systems. whether which product can be recommended for that particular customer. So whether user would like to have that particular resource or not. So all those things can be uh, the real-time applications of this navigation classifier. So advantages, it is easy and fast to predict a class of test data. It also performs well in multi-class prediction. So when assumption of independent codes, then it will work better. It performs well in case of categorical labels compared with numerical labels. So disadvantages, if categorical variable has a category which is not observed in training data set, then it will assign zero. So it will lead to zero frequency. So which can just be solved using a Laplace estimation. So that is one important thing which you have to overcome by applying Laplace estimation. So another limitation is we have to assume the attributes are having independent predictors. Okay, so otherwise it will not be possible. It is impossible to get a set of predictors which are completely independent because one attribute may depend on another one. So that is one of the important thing we have to check and we have to apply the algorithm. So now let us see one more case study. As our title is much concentrating on medical image processing, let me show a case study on how a coronary artery disease classification can be done using this X-ray coronary angiogram. So conventional X-ray coronary angiogram is considered as a golden standard for cardiac imaging modality. So we are having a lot of imaging methods for heart disease prediction like X-ray coronary angiogram. We are having IVUS, we are having OCT, optical computer tomography, CT scan image. We have MRI scan. We have ultrasonograph. So a lot of methods we have in cardiac imaging modality. But here in Tamil Nadu, X-ray angiogram is going to be the maximum standard, so golden standard for checking the blocks in the heart, right? So input image of, for the system is captured from conventional coronary angiography, which is going to have a set of frames. So we can select any one of the frame from that angiography and we can apply as the input. Okay, so median filter. So for any image, we need to apply a image pre-processing. So for reducing the noise and the image smoothing has to be done in order to have efficient classification. So median filtering is applied here. So we are having a lot of filtering methods for filtering, any filtering. So which is better, we can apply that. So image enhancement has to be done in order to show the or highlight the coronary artery tree. Okay, so coronary artery has to be visualized well because it will be hidden around the ribs of the uh, bone images, the bones will be there. So we need to hide that and we need to highlight the artery alone. So for that, we are having a contrast limited adaptive histogram equalization is applied, and we have to use mathematical morphological operations to remove the overlapped organs like lungs and other artifacts. And adaptive thresholding is carried out to segment the coronary artery and fine-tune the coronary vessels as a post-processing operation. So once you come up with the segmentation of the coronary artery, so we can find out where the diameter narrowing is present. That is nothing but the block is present. So this diameter narrowing we call it stenosis. So we need to measure the diameter of the stenosis, and based upon the diameter narrowing, we can calculate the percentage of narrowing. Okay. So based on the percentage of narrowing, we can say what's the risk level of heart disease that a patient may prevail. So here let me show uh, an input image. It's an image of left coronary artery. So in a heart, we'll be having two pairs of we are having a pair of coronary arteries. One is the left coronary artery and the right coronary artery. So here I have shown for left coronary artery. So this is supplying the blood to the lungs in order to have our heart muscles to be working efficiently. Okay, so once if there is any block is happening, the blood supply will stop and you'll be getting angina, what we call chest pain and sweating. So once completely obstructed in that blood vessel, so the blood supply and oxygen supply will stop, and immediately the patient will get a heart block and what we call myocardial infarction and or heart attack. So here we are having that coronary artery. This is the input image. So after median filtering, I have smoothening that image and applying contrast emitted adaptive histochemical equalization to enhance the coronary artery tree. Okay. So next, I'm applying morphological opening, closing, and other operations in order to uh, hide the artifacts and showing the coronary artery alone to be highlighted. So after that, I'm applying adaptive thresholding and the length refinement to segment the coronary artery. Okay, so this is the segmented coronary artery. So from the segmented coronary artery, we have to crop a particular portion where we can visualize that block. Okay, so once you are cropping the particular portion, so we have to calculate the diameter of each and every row, and we have to see where you are having the maximum width and the minimum width. Okay, so once you are calculating the maximum and the minimum width, we can calculate the percentage of stenosis or percentage of narrowing using the formula 1 minus diameter of stenosis divided by diameter normal into 100. Okay, so once you calculate that, if the percentage is less than 50%, then the patient is normal and there is no risk of CAD. So if the percentage is coming around 50 to 69%, so then there's a moderate level of coronary artery disease possible to that particular patient. If it is more than 70% to 99%, then it is severe. So there is high level, high risk of CAD. Okay. So here you can see this right coronary artery. So we are left coronary artery where we can segment the portion. Okay, and I have shown here. So this is a normal artery. So there you don't have any blocks. So here you can see minimum width is 13 and the maximum width is coming around 20. The stenosis rate is 35. So it is less than 50. So there is no stenosis. So the patient is safe. So here you can see the block where the minimum width is 5 and the maximum width is 10. And stenosis rate is coming around 50%. So it is moderate. So the patient is moderately suffering from CAD. So here if you see the blood is very much high. So minimum width is 4 and the maximum width is 15. So it is having severe blood here. So I suffering severely from the coronary artery disease. So from that, okay, automatically once you crop, it is going to calculate and it will give the second opinion to the doctors. So, so it's a kind of characteristic level classification system from the medical image. So we can apply the previous two classifiers to the data set and we can confirm the same from this medical image and you can compare your results. Okay, so that is going to be non-interventional method. Okay, so applying the KNN and navigation and uh, classifying whether the patient is having predicting the result is having heart disease or not. But this is interventional method, so we need to uh, uh, inject the catheter and we have to take the image, and from that image you are going to check the block. Okay, so this accuracy and that accuracy, this result can be we can compare and we can come up with the uh, performance evaluation. So sensitivity, specificity, accuracy, precision, all this you can calculate it, and you can see how the performance of the system is present for the classification algorithm. Okay, so true positive, false positive, and the true negative, false negative, all these things you can calculate. I hope you know very well about these metrics. Okay, true positive value, negative predictive value, and the positive predictive value and accuracy. So accuracy has to be very much high for any system. So with this, let me stop. If you have any queries, you can ask, Madam.
Okay, sir. Now, participants, you can just ask any queries if you have by unmuting yourself. Sir is willing to answer your queries.
Participants, do you have any queries in my presentation?
So you can just
on the
unmute yourself,
algorithms?
introduce yourself, and ask the questions.
Your voice is breaking, ma'am. Sudha, ma'am.
Participants, Any queries you can ask. Okay.
So you may have doubts like
Sir, if
which algorithm can be applied. Yes, ma'am, you can ask.
no, sir, am I audible, sir? Now?
Yes, ma'am.
Yes,
I
ma'am.
can hear. I can hear you.
Okay, okay, okay.
Any queries, ma'am?
I think there is no
So
questions in the
no
chat
queries
box
means
also.
two things we can see. One is it is completely clear. You may
Okay.
not
I will
understood
take it in the positive, sir. I hope everybody would have understood whatever
the
whatever
concept.
about the classification. So I will just, ma'am,
Thank
shall I
you.
proceed with?
Yes, sir, yes, sir. So you
Okay,
can
ma'am.
proceed.
So it is my pleasure to, in fact, deliver the vote of thanks. I am greatly indebted on behalf of the Department of Biomedical Engineering, PSNA CET, to thank Dr. A.H. Nandakishore, Assistant Professor, Department of Computer Science and Engineering, PSN College of Engineering and Technology, for delivering a wonderful lecture on classification techniques. Though it was two basic classification techniques, he explained it in with such a elegant way with some very beautiful examples. Even I was fascinated by the probability examples he gave the naive Bayesian classifiers. We are indeed greatly indebted to you, sir. Thank you very much.
Thank
It
you,
was a
sir.
great
Thank you very much,
session, sir.
sir.
Thank you. Thank you very much, sir. On behalf of
Thank you,
the
sir.
organizing team, thank you.
Thank you,
Thank you,
ma'am.
one and all. Thank you.
Thank you, sir. Thank you, sir.
Thank you, ma'am.
So I have to thank once again our principal management, our beloved biomedical HOD ma'am, as well as our department CSC HOD ma'am also for giving me an opportunity to present the topic. So thank you one and all. So thank you participants. So hope you will be applying such a kind of algorithms in your research work. So better algorithms are available, so you can choose it. Before going on to that, so basic algorithms you can implement for your comparison purpose. So such a basic algorithms, because Python implementations are there nowadays, so very easy to implement. So we no need to go much on MATLAB other implementation. So Python implementation will be very much easier. So you can go on this machine learning and deep learning algorithm implementations. So which will be very much useful for your research work. Thank you. Thank you, Amit. Thank you. Thank you, sir. Thank you, ma'am.
Thank you very much, sir. Thank you.
Shall I leave now, ma'am?